You can put the results of these questions into variables, into a special variable type called bool. Bool is less than 0 equals number is less than 0. And then inside of this if statement, I can replace this with is less than 0. Notice that when I named this variable, I didn't put any spaces in there because you're not allowed to have spaces in your variable names. And I capitalized the first letter of each word. This is what we call camel case. So when I run this, 0, nothing happens. -5. There we go. This if statement triggered because it did the logic here, put the result in this variable, and then asked for the result here. I can also check if the opposite of this is true. For example, I can put this is the not symbol right here. The exclamation point means not. So if not less than 0, then good thing this isn't a negative number, exclamation point. 5. Because if number is less than 0, this is false, and not false is true. In fact, false and true are actual keywords that you can put in here. I can do this. False. And now this will always execute as true because not false is true. And it doesn't matter what I put in here. I can put -100. If I put true, then it doesn't matter what I put in there either. I can also use the not symbol directly around my logic. So I can do this. If not number is greater than 0. And then I don't need this boolean here at all. $100. And what it did is when the program ran, it checked the value, which was 100, and if 100 is greater than 0, then this is true. So even though this is true, it didn't print out because we're reversing that. So true not is false, which is why we don't see, good thing this isn't a negative number here. If I did that, please enter number 100. Good thing this isn't a negative number. I could also, in this if statement, just put number like this, and this is totally valid code. And what this will do is it will trigger true if number is a non-zero value. But if it is 0, then it will trigger false. So if number, you typed in a non-zero value, exclamation point, 100, there we go. But if I put 0, it didn't show up. In fact, when I put 0 in here, it was false, so it did this if statement, and 0 is not less than 5, the -5, so it didn't print this out either. If I had put -5, -5 doesn't count as a 0 value. So when it does the if statement here, it doesn't care if it's a negative or a positive, it just cares if it's 0 or not. And anything that isn't 0 automatically evaluates to true. But you can do really complicated questions with programming logic. Right here, we're only asking one thing at a time. You can actually ask multiple things at a time. Before I write the code to do that, let me clean this up a little bit. Like so. So I can do something like, if number is greater than 1, if I type in the number 5, then we can expect it to say true, because 5 is greater than 1. Enter number 5. That's true. If I type in the number -5, it's false, because -5 is not greater than 1. If I did the equal sign and I typed in 5, this would be false. If I did the not equal sign, it would be true, because -5, it does not equal 1. Let's see that. -5. And I could also do the greater than or equal to or less than or equal to, and it would work as you would expect. But I can also do some really interesting things like this. If number is greater than 1 and number is less than 5. Now this if statement will only trigger true if the number is 2, 3, or 4. If it's anything other than 2, 3, or 4, it won't work. 2 is true. 3 is true. 7 is false. 1 is false, because 1 is not greater than 1, and because that happens, this equates to false. But 1 is less than 5, so this is true. But the AND operation works in such a way that both of these have to be true in order for the complete result to be true. But opposed to the AND is another operation called OR. And these right here are pipes. They're the pipes that you'll find by holding Shift and pressing that key just above the Enter key. And you'll get these. 2 of them like this makes an OR. And with an OR, only one of these has to be true. And if just one of them is true, then this entire statement will evaluate to true and it will run the if statement. So in this case, I can actually type anything, because it's impossible for me to pick a number that makes this statement false and this statement false. So let me show you. If I do -1000, it counts as true, because -1000 is not greater than 1, but -1000 is less than 5. And because the way an OR works, false or true evaluates to true. If this were an AND, then false and true would evaluate to false. There's a diagram that computer scientists draw out called the truth table that shows how this works. I'm going to write that out right now as a comment up here. So if we have true and false versus true and false, this is for AND. If true and true, then you get true. True and false is false. False and true is false, and false is false. Let me make this a little bit clearer here. So these are the headings up here, and these are the results. If I were to make this same table with the OR, and looks like this, and OR looks like this. True and true is true. True or false is true. False or true is true, but false and false is false. There's actually one more operation like this called the exclusive OR. And the exclusive OR looks like this. It's this caret, Shift 6. And with the caret, true and true is false. True and false is true. False and true is true, but false and false is false. Now the logic behind an exclusive OR is like when you ask somebody a question, what kind of grade would you like, an A or an F? Picking one is mutually exclusive to the other one. You can only have one of those. But if somebody came to you and said, would you like ice cream or chocolate? Well, why can't I have both? In the grades example, the exclusive OR is the OR that you're thinking about, and in the dessert example, the regular logical OR is the OR that you're thinking about. I've written up a little program that will give you some practice with all of those logical operations. Let me just put that code in here real quick in main. I'm going to replace all of the code I have in here with this big old bunch of code here. This is a little application that I just wrote, and it checks to see how well you know your operations. The first thing it asks is for a seed, and this seed will determine how the quiz generates. So if I give it the seed 1, 2, 3, 4, 5, as long as I put this seed in here, it'll start with this question each time. This quiz is asking a simple Boolean question. It's saying if 4 is greater than 4, exclusive or false. So this right here is asking if 4 is greater than 4. 4 is not greater than 4, so this should be a false. And false, exclusive or false, is also going to be false, which means this if statement will not trigger, and the answer will be F. Because the if won't trigger, the else will, and it'll print out F. If I press enter, it goes ahead and shows me exactly how that logic worked, exactly how I explained it. So 4 greater than 4 is false, false, exclusive or false is false, and I was right because I put F. Then it generates another question. 5 is less than 7, well that's true. True or false, one of them is true, and because OR only requires one of them to be true, that whole thing is true. And there it goes and shows me the same logic. I've got this code linked at the bottom of this page, actually just below the YouTube video, and you can go ahead and try this code out for yourself and test yourself against it to see how well you understand the Boolean logic. It doesn't score you, it doesn't grade you, it doesn't keep track of how many points you've gotten right and wrong, but if you'd like to modify the program yourself to add that, you're more than welcome to. You can always quit by pressing Q. There's a lot of code here that I used to write this program, and some of this code you've never seen before, but hopefully you'll see the rest of this kind of code in this lecture as I continue giving it. So let's start talking about what that program does. The way that that program is able to do things over and over is with a loop. I'm going to go ahead and erase all of this code so that I can show you in simpler terms what a loop is and how the syntax looks.